Here's some links you can follow. We've got a GitHub repository that you can clone that should have all of the source that you need to follow along. There's the link. That bit.ly link was obviously, that's a shortened version of the second one there. On the left, obviously, that's our POW Summit Wi-Fi that you're already familiar with, and on the right, that's the Wi-Fi that Diego spun up with his Raspberry Pi here. And once we get going, once you have the source code from the internet, then feel free to disconnect from that and reconnect to Diego's POW workshop Wi-Fi here with the password longlivepOW. And it's on that private network there that we'll be doing our mining and building our own chain from Genesis. And so if you're going to have to bear with me here. I don't do mirroring with this computer very well, so I'm going to have to do a fair amount of looking over my shoulder. But we'll make it work. And so what you'll be cloning is this repository here. And we've got on the README some instructions that we'll be following along with here. And there's a geth binary in here. That's for Mac. I think maybe most of you are on Mac, and if not, there are instructions here to clone the actual geth binary if you're on Linux. What's that? Oh, well, let's make it not private. Good catch there. Where am I going? Down. Yeah, down to the danger zone, right? Oh, good. Oh, shit. Oh, no. Good. Well, we are high security. Yeah, if you can do it, Chris, that'd be great. Yeah. And so generally what we're going to walk through here is we've got a custom Genesis block set up, and we'll poke around in that a little bit. I'll give you some overview of what we're configuring and why it looks the way it does. And then from that Genesis block, where you're going to use geth, which is going to be the artifact created from the core geth repository. The core geth repository is what we three work on now primarily. Diego also experienced with Java and the Besu client. Core geth is the primary client for Ethereum Classic. It also supports Ethereum and a few other networks. Differentially from the upstream Go Ethereum, from which core geth is a derivative, we've done what we needed, and what we needed to be able to support Ethereum Classic based on that code base, which was and is originally quite brittle and quite dedicated to the interests and uses of the Ethereum Foundation. And so we've made more than a few tweaks, I think it's safe to say, in order to be able to support Ethereum Classic and also other networks. The vision there is to make it as extensible and hackable as possible for EVM-based chains. Okay, so Chris is telling me that we are now public, so you should be able to find it. All good there, I think. So just a simple clone here, and once that's cloned, we'll have something like like this here, and I'll move this over to a new. Okay, so this is just the editor view of that repository. And what I've got here is the README on the left. That's the instructions that we're going to be following along with. And on the right here is the Genesis JSON. Just a quick overview of the Genesis and why it looks the way it does. If any of you have done something similar with the Ethereum Foundation Geth client, you'll notice a few differences. Notably, you see these EIP fields here. And that's one of the core architectural differences that we've made with upstream Go Ethereum. We've done that, we call it features, not forks. The way that upstream Ethereum, Go Ethereum configures their client is based on sets of rules that have been introduced in some given fork, and usually those rules are 4 or 5 or 6 changes that happen all at once at a certain moment in time, and then those are configured with a single toggle, which for the developer and hacker makes the code base extremely difficult to work with if you want to do anything besides what the Ethereum Foundation wants to do, because you need to activate certain EIPs all at once as a bundle, an inextricable bundle. And so what we've done is extricate those EIPs to their own features, and so all of those features can be configured individually and independently. And so, for example, EIP2 and EIP7 were both Homestead EIPs. That was one of the very first forks on Ethereum. And so instead of having a Homestead block configuration value, we now have the ability to configure those EIPs independently. And so that's what we're seeing here. And the list of all these EIPs is basically a standard out-of-the-box list of the EIPs that are going to be activated both on Ethereum and Ethereum Classic. Down here we've got Ethash, so we know that that's going to be the mining algorithm that we're going to be using, and we list the protocol versions differentially from upstream as well. From this Genesis, as long as we all init with the same Genesis, we're going to have the same chain configuration and protocol rules. And so that's going to allow our clients to play together, speak the same language, and expect the same values at the same time. So following along, everybody have any issues, any questions yet so far getting it cloned? The important piece of the puzzle that you're going to need next is to have Geth. Any issues getting Geth? There is a binary included with the repository. If not, if you're on Linux, you'll need to clone and build from source, or download from the releases section at the GitHub repository. Okay, so blast off here. So here on the left, that left pane there, I've got the Power Workshop repository set up. You can see the contents in there. We've got our Genesis JSON, and that's what we're going to be working with first. So the first step in the order of things here is going to be to init our Geth data directory. Data directory is where it stores all of the chain data, obviously, and the way that you init that and the way that you tell Geth which configuration you'd like to use is to init the Genesis, and that Genesis, as you've seen, includes the configuration for the protocol as it goes forward. So we'll do an init. And so what I'm doing here, flags of note are configuring the data directory here just local to the project root, configuring the network ID, and we're calling the init command, passing just the Genesis JSON. And so once we call this, we should see a few log lines about instantiating the database and configuring the protocol rules. And we've successfully wrote Genesis state, so we're good to go. I see no hands, so we'll continue to move on. If you do have any issues or questions, please just shout them out, raise your hand, and I'll keep staring into the light as best I can for you. So we've got successfully wrote Genesis state. That looks good. So now we get to fire it up. And as I do this, Chris here in front has done the same thing. And so we're going to eventually connect our peers together. So here's the full command that I'll be running. Geth datadir. As you can see, there's no more init command. We're just running geth straight. The default behavior for geth obviously is to run as a client on the network. And as long as we pass the same datadir, it's going to know what Genesis to use and which configuration to use. We're turning on RPC over HTTP with lenient permissions there, configuring a full sync node, and as you can see there, I've got boot nodes listed, and that's Chris's node key, and local IP. Again, that's to the private WLAN that Diego spun up. So. As a catch here, before I begin this, I need to connect to Diego's POW workshop. This happened before. So we'll do a rescan here. There we go. So the POW workshop is available. Okay. So now that I'm on Diego's WLAN, I am going to start geth up, and I expect it to connect to Chris's node. Oh yeah, yep. Chris has reminded me I should point to which command I'm using here from the README. And this is here under the section 5, start your private node, geth datadir workshop. Yeah, that's which line? 52. Yep, line 52 in the README. And as you can see, we're using Chris's node key. We're all going to be using that as a boot node, and we're going to be on this local address here on the Raspberry Pi's network. All right, so I just punched geth. We started her up. Quick read through the logs. Everything looks to be normal. As you can see, we've got an HTTP server started. That's going to be an RPC endpoint for us. The RPC service that geth provides supports several different transport types, HTTP being one of them. It looks like we're up and running, and as you can see, we don't have any blocks yet on the network. Nothing's happening, but we're just by default scanning for peers. Geth is turned on. So we're ready to go. Moving on to the section mining here. Yeah, so if you don't have a wallet, and I'm not going to assume that you do have a wallet or account set up yet, eventually where this is going to go, we're going to go use MetaMask, and we're going to send some transactions back and forth once we've started mining and accrued some currency as rewards for the blocks that we're mining on this network. If you don't have an account set up, there are two ways of creating an account. One of them is going to be to go through MetaMask. That will do the work for you. Alternatively, you can use geth to create an account for you. But I'm taking the MetaMask route, and we'll show you how that happens here. So I've got MetaMask installed as an extension for Firefox. If you don't have MetaMask installed yet, you just go to the add-ons for whatever your browser of choice is. It's available on all of the standard browsers. This is what it looks like by Dan Finley. And so once you have that, this is the default view on MetaMask and Firefox. And what we're eventually going to do is go to add a network manually. But you can see that I've got an account created already. It's simple, fairly straightforward to just click through. If you have any issues, I'm sure Diego or Chris would be happy to run on over and help you create an account through MetaMask if you don't have one. The important piece is, for me here, is going to be to make sure that I do have this address, because that address is what I'm going to use as the ether base for my mining. Yeah. Good idea. Chris recommends that we, if you may take a moment here to set up MetaMask yourselves, we'll start mining and get this show on the road. So what I'm going to do here is attach, because I haven't started mining through the CLI options right out of the box with Geth, so I'm going to need to attach to the console. The console is an interactive JavaScript console that, again, works over RPC. It's just another transport for the same set of APIs connected to the Geth instance, and by default, that IPC socket is situated right there in the root of the data directory. So we connect, and you can see right away that the client's registered that we've connected, and it shows me the modules that are available. Modules are basic groupings of RPC APIs. And, voila, looks like Chris has started mining. So we've got some new chain segments rolling in here. That Chris has been creating. And so, for example, I could do ETH get block. I think I have to do by number. Latest. And so that's the latest block that I have on the network. And so we can see the under the miner field there, we can see Chris's ether base. That's what account he's chosen to be the recipient of the rewards. If I want to start mining, if I just call miner start, it's going to complain because I haven't set an ether base yet. The ether base is the same as the miner field. That's the target recipient for any block rewards that I may accrue while mining. So I need to get that configured. Let's see, ether base. Oh, maybe it's caps. Okay, so that's my address that I created over in MetaMask. I'm just going to configure that as the ether base for my Geth instance. And now I can call start mining, and that should work without complaint. What you can see here, as Geth is working, is generating that DAG because we're using ETH hash. So we need to have that directed acyclic graph of data generated in order to be able to start mining. So that's the first project that Geth takes on. And once it finishes this first epoch of DAG generation, then I'll be able to start mining, and that'll kick in right away. We should see some logs here start to happen, telling us that we've sealed the potential blocks, and then once those fall about 7 behind the head, it'll confirm those blocks. And again, that's a default. As you may be familiar with the finality, any of these blocks that I win are all technically pending forever, but Geth thinks that they're going to be well confirmed by the time they're 7 blocks from the head. And then I'll be making some money. And so what I can do now, now that we're, there we go, mined potential block. That's great. So number 41, number 42. And then as those fall back behind the head, it'll confirm those blocks for me. And then we can come on back over to our MetaMask instance, and we'll check that I have accrued some rewards for those. Out of the box, those should be about exactly 5 Ether per block. Back to the README, in order to connect to MetaMask and to be able to use MetaMask to see those rewards and to interact with the network by creating transactions and passing some Ether around, I'm going to follow these steps here in the connecting MetaMask paragraph in the README. That's line 71. So we're going to just go through and set up this new network for MetaMask. And this may be useful for using MetaMask in Ethereum Classic anyways. If you'd like to use it with your own node or your own service, that's one of the important security sort of architectures of the way that MetaMask does it, so that if you choose not to use an upstream endpoint to locate your trust for interacting with the network, you can, of course, spin up a node on your own and use that as your point of entry to a network. So we'll go here to create a new network. So we'll call this fake ETC. And the RPC URL is going to be that HTTP endpoint that Geth has exposed for me. By default, that's at 8545 port, and that's just on my local local machine here. So we come on over, punch that in. The chain oh, no, I've already done this, so it's not letting me. Okay, we'll go back. Come up here. Oh, I see. So because that endpoint, we did this test just half an hour ago over in the next room, and I went through these steps. It looks like it thinks that RPC endpoint's a collision, and it's already taken. So I'm sorry, instead of going through line by line and punching those in, which you'll need to do, I've already done that, and so I'm just going to call that ETC workshop test here. Oh, here we go. Yeah, get out of settings. Okay, there we go. Oh, yeah. Yep. So we're making money now. And those are the rewards that I've accrued, and you can see MetaMask is monitoring that HTTP endpoint for new blocks. I think MetaMask does that by polling. If they used WebSockets, they could subscribe to the new head method. But as you can see, I'm accruing rewards. Man, it looks like I'm winning this power race with you here, Chris. Oh, yeah, Chris is going to send me even more. And so as you'll notice, these blocks are happening super fast. And I'm sorry if this is a little too rudimentary, and as if I have a feeling it may be for most of the audience, but the reason that these blocks are coming in at the rate that they are, which is clearly faster than the targeted 13 seconds per block, that's because we started with something near the minimum difficulty, and apparently the combination of my laptop and Chris's and now yours is going to push that difficulty upwards. But that's expected, and that's the feedback loop for managing a dynamic hash rate with ETH hash. Any questions so far? All right, great. Oh yeah, so it looks like those 300 were received, Chris, I think. I don't know if MetaMask shows us that in the activity, but you know, I don't know if I can we can go in here and send Chris some value. We'll find Chris's. Gotcha. I'll send you 100. As you can see, the gas limit, that's coming from the RPC endpoint as well. There's a gas price suggestion API method that's a value that Geth will automatically configure based on the number of transactions and the prices that miners are currently accepting. And 2100 is the floor. And it looks like we are going to confirm this, send Chris 100 Ether, and that's pending. And now, once that transaction is included in a block, the deed will be done, and Chris will be 100 ETH richer. And so that's basically the flow for. I confirmed. Wonderful. So that's about it. That's the basics of spinning up a private network and mining from Genesis, which is to say from square one. Any questions? Yeah. Oh, the question is, what's my take on the 51% attack? I assume you're referring to the 51% attack a few years ago on Ethereum Classic? Oh, just in general, what's my take on it? So a 51% attack is an unexpected chain reorganization. And so the attack is an attack on, it's a finality-based attack, right? So my take on it is that it's expected behavior for chains. This is how proof of work works, is that the chain with the greatest difficulty, which is a measure of the amount of work that's been done on it, as a heuristic, and the only guiding principle for following and building a chain is that you chase the chain with the greatest difficulty. And so a 51% attack happens when there is more hash rate that's unknown than there is hash rate that's known, or at least known being an idea for what is public at the time, or at least what's handled as canonical by somebody. And so typically, everyday world, that's the same chain that we look at. And so right now, if we were looking at this and pretending that this was the real chain, we would together be assuming that our consensus was representative of this true state of the network. But if there were somebody in the next room with one of those big fancy rigs out there working on this same network, and they wanted to defraud me, for lack of a better word, the 51% attack happens when they have the combination of that secret hash power along with an intention to steal my money, and to do so by keeping it a secret that they're over in the next room working as an antagonist. And so Ethereum Classic suffered 51% attacks a few years ago, and the good news is that it worked as expected, which is to say that we did indeed follow the longest chain, and that the protocol was followed. We've since followed that up with some subjective finality measures, which are intended to help individual clients behave in ways that are contiguous with each other, while not interfering with the actual and natural growth of the network according to the canonical protocols that we've all agreed on since Genesis. And now that Ethereum Classic has the hash rate that it does, being the lion's share in the ETH hash market, we are looking forward to removing MES from the protocol in the future, because it's a piece of subjective logic that need not be there anymore, given what we know about the mining environment that we are in right now. Great question. Yeah, thank you. Yeah. So if anybody wants to try 51%ing attack us right now, that would be really cool. But you're going to have to compete with this old ThinkPad, and she's tougher than she looks. But any other questions? Yeah, Chris. Yeah. 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 Historia.
Are there any other benefits other than organization of having the features, not forks architecture?
Yeah. Man, I gave a whole talk on this in Denver once upon a time, centered around the idea of readability. The downside to doing features, not forks for Corgeth is that it's a pain in the ass for us because we want to inherit the upgrades and the logic and the massive amount of work that happens upstream because there are so many features, particularly features that are pertinent to the EVM that are safest and best for us to inherit directly from upstream if possible. That's in part because there's a large amount of testing and review and work that happens that would be silly for us to try to duplicate on the side. Although that is possible, and in fact the first few years that I was working with ETC, that's how we did it. When we forked Ethereum, we also forked the client, and that was permanent. So when we wanted to make protocol changes, it was changes that we were writing by hand ourselves with reference to the spec that was happening upstream. So that's the downside, is that it creates a merge issue because we have divergences in the code base that are really extensive. Because these features have been introduced consistently over the last 5 years, and so they do add up in the number of places that they touch in the code. The benefits are that the code, in my opinion, and hopefully in our opinion, is that the code reflects the spec better. So that now, for example, I wish I had this brought up here, and if I weren't looking over my shoulder, I might be bold enough to try to point to actual places in the code. But the benefit is that when you write spec in a feature-based way, so those are, let's say, EIPs, EIP 4844, EIP 1559, all of those specs are written distinctly, and then they're brought together to happen coincidentally, to be turned on at the same time, simultaneously at some point. And so keeping them distinct from each other allows not only readability in the code. So for example, when you look at the code, you can see with Corgeth, you can see, okay, this is where EIP 752 happens. And you can find usages for that method. And you can find, when you just look at the code, you can see that that is the logic and the implementation. And you can understand that it's representative of some specification in a one-to-one way. You're also able to test things distinctly and individually. Whereas with the upstream implementation, which bundles all of those features together, it means that you can't have tests for any specific feature without testing everything all at once. That is convenient when you expect that there is one path forward and one chain and one way of doing things, because you can't imagine an alternative universe where some EIP might be omitted and you might want to run some tests without that EIP. But for us at Ethereum Classic, because we do omit EIPs, specifically ones that have to do with monetary policy and a few other broad heuristics that Bob's already pointed to, but that was the impetus for doing features not forks, is because we do need to be selective about this in our reading and our decisions about those EIPs. And when we look at their forks, we look at their forks as composites of EIPs, not as take it all or leave it all. Great question. Yeah, all right. I think I'm off the hook. Thank you very much for your time.
Thank you so much.